In this video, we're going to look at the sum to product and product to sum identities. These particular identities are a little bit more complex than the previous ones, as they have a number of more details in them. We're going to start with the product to sum identities and look at here that you'll notice that we have a product of sine times cosine, and we end up equaling to the addition of, in this case, two sine functions. For sine times sine, we end up a subtraction, or technically a sum of a negative cosine plus an actual cosine. You'll also notice that the angles in them is x times y, so that they don't have to be the same angle, but they can be different angles. And that they compose in different ways in the other two new functions that arise. So this sine of x times cosine of y equals to this entire thing right here, where x and y are the same as they were back here, but they smash them together into the functions we have. So you have these four different identities for product to sum identities. The first types of questions you might be asked are, express the products as a sum or a difference. So we have the sine of 5x times the sine of 2x. And for an identity like this, you're looking at it and going, well, I don't know how to effectively simplify this in any way. There are ways that you could potentially work with the interior here and manipulate it, but our best bet is to simply use this sine of x times the sine of y identity, which is equal to 1/2 cosine of x minus y minus cosine of x plus y, where my x in this case is 5x, and my y in this case is 2x. So if I'm very careful about how I do that, I'm going to have 1/2 times the cosine of my x, x being 5x, minus my y being 2x, minus the cosine of my x being 5x, plus my y being 2x. I'm going to close those brackets, and I'm going to end up getting equals to 1/2 times the cosine of, in this case, 5 minus 2x is 3x. Again, I can do algebra within a single cosine function. And then I can do the same thing over here, giving me the cosine of 7x. And now you're looking at it going, well, I changed these sine functions being multiplied together into a subtraction of two cosine functions. It's also important to note that there's not much more I can do with this, given that this angle and this angle are not the same. At no point can you take a cosine of 3x minus a cosine of 7x and say maybe you consider you get the cosine of negative 4x. We can't subtract the interiors of two different trig functions at the same time, unless they're, again, we simply can't do it. The insides are going to be stagnant, and the only thing that can change these trig functions is if we were to use identities. So if the question had us do more work, we might want to go ahead and try and take these two and smash them together in some way. But it might actually be more beneficial for us to utilize the sine of 2x back here with a double angle identity if we wanted to manipulate this thing in any feasible way that would reduce it to no longer have multiple angle values inside these trig functions. But again, given that it said express this product as a sum or difference, that particular example is done. In the next example, we're going to have the exact same question. It's the cosine of 7x times the cosine of x. In this situation, we're going to take this product and we're going to smash them together and create a sum in this case. The identity here is going to be this last one in this list of product to sum identities. Cosine of x, cosine of y is equal to 1/2 of all this. And I'm going to go ahead and very carefully deal with that, making sure that every time I see an x, it's going to be 7x, and every time I see a y, it's just going to be x. That might be confusing to look at the first time, but again, my cosine of x is my first x value. My first x value is 7x, and my second value is a y, and my second value in this case is x. So again, that's how I'm labeling all these values. So the cosine then of 7x minus x in this case, this gives me 1/2 multiplied by the cosine of 8x plus the cosine of 6x. Now this might actually be more beneficial for us to work with, given that everything in here is now some form of a double angle that's even. We can work with this and potentially manipulate it further, but again, the question didn't say to do anything other than convert it from a product to a sum or difference. And now I have the sum of two trig functions, so that particular problem is done. These identities for the product to sum are very rarely used in verifying identities. They can be used. Again, it's not the case that they won't ever be used, but it's rare that they'll be used in such a way that you won't be looking at odd interior angles, manipulating them to get to an even interior angle, so that you could potentially, hopefully, use a double angle identity to reduce it further. That's all the examples we have for the product to sum identities. We'll look at the sum to product identities in another video.